So in this problem, we're shown a graph of a parent function, that's the dotted black line, and the transformed function in blue, and we're asked a number of things about the transformations, and we use these little pull-down menus to make our selections here. And you can see there's a bunch of choices. We're going to go through this in detail. I want to go over this example because even though we've been talking about vertical and horizontal shifts and stretches, it's useful to talk about this in detail with a parabola, because sometimes it's tough to see what a parabola is really doing in terms of a stretch or compression. So let's talk about that first, the stretch and compression. And let's see, is this specifying vertical? Nope, it's just all stretches and compressions. Oh, well, yes, this is vertical. We're not doing horizontal stretches and compressions. Okay, so this is vertical. All right, so what I normally do with these is I say, okay, where does my parabola start? Like right there. Okay, and if you look at the parent function, see how it goes over 1, up 1? Well, let's see what this one does. It goes over 1 and, oh, not quite up 1. So I know this is going to be a compression, but I don't know exactly what that fraction is. So let's try and find a different grid crossing. I'm going to go over 2 and see how high up. Okay, I didn't quite get up to a grid crossing there. I got to something that was almost 3. All right, so let's go over to this one. This is over 3 and up a bit. So that is 1, 2, 3, 4, 5, 6. Okay, so I'm over 3, up 6. Now, here's the question. What did the original parent function do? Over 3, up how much? Well, it's off the graph, but you know this is an x squared function, right? This is the parent function. So if that's x squared, then that means over 3, up 9. And mine did over 3, up 6. So how do you turn 9 into 6? That's the question here. Well, you multiply it by 2/3, and that equals up by 6. So what that means is we have a vertical stretch. I'm sorry, this is less than 1, right? Vertical compression of, and then you take that factor of 2/3. Vertical compression of 2/3. Now in the drop-down menus, you won't have to go through all this detail because it'll have a few choices for you. And it will be clear what you're supposed to do. Like it'll say vertical compression 2/3, vertical compression 3/2. So it'll be a limited set of choices. And you can also use that limited set to kind of narrow it down quicker than we did right here. But this is the full detail method in case maybe you're going backwards and trying to figure out the function just based on the graph. So now I'm going to look at vertical shifts right here. And this is easy. You can see that it just went down 4. So we would say down by 4. Horizontal shift next. You can see it has gone over by, let's see, 1, 2, 3, 4, 5. So that is left by 5. And you keep on working through this. Write g of x using function notation. Okay, so we're going to take those transformations that we've been talking about, and we're going to turn this into an equation. I use my vertical compression first. 2/3 times f of what? Well, it's x plus 5, because I know I have a horizontal shift 5 to the left. And I also have a shift down by 4, so it's a minus 4. Okay, that's my function notation. And now we can turn it into an equation. 2/3 x plus 5 squared minus 4. All right, write the domain of g using interval notation. Well, this should be pretty easy if you just look at the graph. You can see this thing goes off forever in both directions, right? There's no holes, there's no interruptions, so we just say -infinity to infinity for domain. And the range starts at the minimum value right here, this point, which is -4, and it goes up forever.